Hello guys, welcome back to my YouTube channel. So today's daily LeetCode question is first missing number. So we have to find the first missing number in array which will be positive. So we are given an unsorted array of nums. So we have to return the smallest positive number that is not present in the array. So we need to implement this in log n time complexity and 0 of 1 space complexity. So let's look into the approach. So our basic approach is to understand the concept. We will use a hash set. So we will store each and every element in the hash set to avoid duplicates. So the number will be in 1 to n. So the number will be 1 to n because the size of the array is n, and the starting from 1 we can find the all positive numbers. So we no need to add any negative numbers to the hash set. So if any number is missing from 1 to n, so we gonna return that, or else we will return n plus 1. So this is the basic approach. So now this takes a time complexity of big O of n. So we need space complexity of big O of 1 and time complexity of big O of n. Hash set will take time complexity of and time complexity both big O of n. So this exceeds our algorithm. So we will find another way to solve that. So let's look into the optimized solution. So let us say our array is this, and our solution should be 2 because 1 is present, 4 is present, and 3 is present. So missing number is 2. So we need to find out. We will first write the indexes of the array. So in first loop we will find out if 1 is present in the array or not. So we will first for loop is for finding the 1. If 1 is present in the loop, so we will going to implement next step, or else return the 1. First for loop for finding 1, and next for loop will be we will be modifying the numbers which are less than or equal to 0 or greater than our n. So we will be modifying these values to 1. Let us say in the next for loop our array will look like some like this: 3 4 1 1. So this will become our new array after the second for loop. Okay, now we will go to the third for loop. In third for loop we will be modifying the indices. So based on the if see 1 2, so here the value is 3. So 3 minus 1 is 2. So we will add, so the size of the array is 4, right? So we will add this value 4. So 1 plus 4 is 5. So this will become 5. So next 4 minus 1 is 3. So in at third index the present value is 1. So 1 plus 4 is 5. So again this will be also 5. At next here we have fifth index. So 5 minus 1 is 4. So here see we are going array out of bound. So we need to apply modulo operation also. Modulo operation of size 4, so that the value is less than 0 to n minus 1. So that should be our goal. So if 4 modulo 4 is 0, so at the third index we will add the size of the array. So it will become 8. So again it will have encountering 1, so 5 it will have, we have already modified 8, so it will be again 8 plus 5 4 is 12. So now at the we will use again a loop, the third loop. The third loop will be, now our array will look like this: 12, 4, 5, 5. So you can observe there are some values, there are maximum values which are greater than size of the array. See, 12 is greater than size of the array, 5 is greater than size of the array, 5 is greater than size of the array. So we will iterate to the loop and find which index is not greater than the size of the array. So 0th index is greater than size of the array, 1 index is not greater than size of the array. So we will return 1 plus 1, 2. So that's it. So if you will iterate till the n, you will not find any value that is not greater than n, so you can simply return n plus 1. So this is my approach. So thank you. Code is in the GitHub.